Let's talk about another problematic complex function, that being the complex square root. You see, for any complex number, let's take 1 plus I, there happens to be two square roots of that number. And so like before, we can't just have a function where you have one input and it gives two outputs. That quite literally goes against the definition of a function. So let's proceed just as we did before. We'll define some sort of Riemann surface such that there are two branches. One branch in which our input will map to the negative square root, and one where our branch will map to the positive square root. Our branch cut will be from 0 to infinity, just like it was with the logarithm. But now you might be saying, wait, I thought the point of complex analysis was so that we could take the square root of negative numbers. Well, now let me introduce you to the possibility of choosing our branch cut. See, we have to choose one line that starts at 0 and goes out to infinity. But there's nothing stopping us from choosing something like the non-negative real line for our branch cut. This square root function, where I've defined the branch cut to be over the non-negative real line, can now take in negative values for its square root. So now I can use this square root where I've taken out the non-negative real line, and if I take the principal branch of the square root of -1, I'll get I, and if I take the next branch of the square root of -1, I'll get negative I. Being able to choose our branch cut is really nice. Say you are integrating the log of z over some function of z from 0 to infinity. Well, if you wanted to do a keyhole contour, we couldn't use this back end of the contour that goes through the negative real axis because there would be a branch cut. But I could choose my branch cut to be over the positive real line, and then everything is fine if I do this contour integral because I'm never actually touching the positive real line, I'm just taking a limit. And so I didn't even need to choose one of the four main axes. I could choose a branch cut that starts at 0 and follows this line that goes 45 degrees from the negative real axis. I could even pick a spiral that starts at 0, and as long as it's continuous and approaches infinity, we should be good. I should also mention that if we're choosing a function like the cube root of z, we use the same procedure except we use 3 sheets of the complex plane instead of 2, and we just have 2 branch cuts. Now, what if I want to take the alpha-th root of z? Well, if alpha happens to be like an irrational or a complex number, then we would take e to the 1 over alpha log z, because that's the same, and then the log, we've already been over its Riemann surface, so we're good there. And then if alpha happens to be some rational real number, then what we can do is just write it out as its rational p over q form, and then work with it as we did the cube root or the square root. And so that's all we have to deal with when we're doing roots in the complex plane. Thanks so much for watching, and I hope you have a nice day.